Hi everybody, and once again welcome to Pankaj's Echelon tutorials. In this today's session we are going to do some numerical, some problems on rational and irrational numbers, and this is for the IGCSE curriculum, and the level is the ninth grade. Okay, so let me write down for you. This is for IGCSE curriculum, and this is for the ninth grade. Okay, now in the ninth grade for IGCSE students, there is a chapter called numbers. Okay, in that unit numbers, you have to study a lot of things regarding numbers. Okay, so that is what we are doing. I think in the previous 2 3 videos or 4 videos, we have been doing these numbers only. So we have reached a stage when we can start now discussing what are rational and irrational numbers. Okay, and in fact, we have discussed what are rational and irrational numbers in the previous video. Today, we are going to solve some numericals or problems based on rational and irrational numbers. Okay. So the first question that I have taken is this one. Uh, are these numbers rational? If yes, why? And these are the numbers given. 3 upon 7, 1 by 2, 5.14, 0.6 bar. Okay, these are the numbers. Now you have to answer whether these numbers are rational or not, and you have to give the reason if why they are rational or why they are not. Okay, so first one is 3 upon 7. So the answer is yes. In fact, all are rational numbers. Okay, all these numbers 3 upon 7, 1 by 2, that is 1.5, 5.14, and 0.6 bar, all are rational numbers. Okay, yes, all are rational numbers, and the reason is because all these numbers can be converted and written in the form p upon q. Okay, so all these numbers somehow you will be able to write in the form of p upon q, where p and q are belonging to integers, that is p and q will be integers, and your q will not be equal to 0. Okay, in any case the q should not be equal to 0. Okay, so if you can write these numbers in this form p upon q satisfying this condition, then it is a rational number. Why? Because rational number definition says that any rational number is that number which can be written in the form of p by q, where p and q belongs to integers and q is not equal to 0. So the very first number 3 upon 7, oh, this is 3 upon 7, not 2. So the very first number 3 upon 7 is a rational number. Why? Very clear, because 3 and 7 both are integers, and moreover this denominator is not equal to 0. Okay, it is 7. Now second one is 1 by 2, that is 1.5. Now this 1 by 2 is a mixed fraction. Now you can easily convert it into an improper fraction, and you can write it as 3 upon 2. So 1 by 2 is same as 3 upon 2, and 3 upon 2 is again in the form of p upon q, where both 3 and 2 are integers, and this denominator में जो integer है, that is not equal to 0. So again this is a rational number, right? Coming to next one, 5.14. Now 5.14 can be written as 514 upon 100. Now these are interconversions. Okay, you should know how to convert a decimal number into fraction, a fraction into decimal, a mixed fraction into improper fraction. All that you should know. Okay, and you have studied all this in your lower classes. So 5.14 any day can be written as 514 upon 100, which can be further reduced to 257 upon 50. Now look at this 257 upon 50. Isn't it of the type p upon q, where p and q both are integers, moreover q is not equal to 0? Yes, it is. So therefore this number is also a rational number. And last but not the least, it is 0.6 bar. Now 0.6 bar means 0.66666. So 6 is recurring. Okay, so this is a recurring decimal. Okay, or you can say this is a recurring fraction. Now this definition of rational number even says that any recurring decimal is a rational number. So 0.6 bar being a recurring decimal, it is a rational number. Or you can do one thing, this 0.6 bar can be converted into a fraction. Okay, 0.6 bar can be converted in. Now this I have dedicated one video on this, how to convert a recurring fraction or a recurring number into a fraction. Okay, so 0.6 bar you can easily convert it into fraction. It will be 2 by 3, and 2 by 3 is satisfying this particular rule, that is p upon q. Pq belongs to integer and q not equal to 0. Is that clear? So even this is a rational number, right? Now the next question is question number 2. Why are the following numbers irrational? Okay, this is the second question we are doing, right? Why are the following numbers irrational? Okay, now root 2, root 5, pi, cube root of 2, all these four numbers, given, they are irrational. Now they are saying that they are irrational, but you have to give the reason why they are irrational. So the answer will be root 2, root 5, pi and cube root of 2. All are irrational because first let us take this pi. Now pi is equal to 3.142 dot 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 dot. Okay, now when there is a dot 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 dot, that means it is a number which is a non-terminating and a non-recurring number. Okay, it is a non-terminating and a non-recurring number. And any non-terminating and non-recurring number has to be irrational. That is the definition of irrational number. So you can say by definition of irrational number, pi is having a value of 3.142 dot 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 dot, which is a non-terminating and non-recurring fraction. Okay, non-terminating, non-recurring, and therefore it is irrational. So we have given the reason for this pi. Now, this pi cannot be written in the form of p upon q, for where p and q are integer and q not equal to 0. So this pi ka value, which is 3.142 dot 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 dot, this can never ever be written in the form of p upon q, where p and q will be integers and q not equal to 0. You will not be able to bring it in this form. Now this form is a rational number. Okay, so you cannot bring it in this form. Therefore, this number pi is not a rational number. And if it is not a rational number, it has to be irrational number. Done. Now, the remaining three numbers, if you see, it is root 2, root 5, and then cube root of 2. Okay. Now, what happens is any number of the form root n, where n is not a perfect square or a perfect cube, is said to be an irrational number. Now, this is also discussed in our previous video. Like any irrational number can be of the form of root of something, and that something has to be not a perfect square or not a perfect cube. Okay, then it will be irrational. Now, if you see root 2, in root 2, 2 is not a perfect square. In root 5, 5 is not a perfect square. In cube root of 2, 2 is not a perfect cube. Okay. So because this 2, 5 and this 2, these are known as radicals. Okay. Because the radicals, so I'll write here, because the radicals are not a perfect square or perfect cube. Okay. Therefore, these numbers are irrational number. Okay, if the radicand is a perfect square or a perfect cube, then that particular number will work out to a rational number. Okay, it will get converted into a rational number. So you cannot call it an irrational number. But if the radicand is not a perfect square or not a perfect cube, then definitely it is an irrational number. So this is the reasoning behind that. Let us go to next question, that is question number 3. Which of the following numbers are rational? Now, out of this pi by 2, now pi is an irrational number. An irrational number, when divided by a rational number, will give you an irrational number, right? So pi by 2 will also be irrational. Root pi, it is an irrational number because it is having a non-perfect square inside the radical side, or you can say the radicand is a non-perfect square, so it is an irrational number. Now, root of 17 the whole square. Now, root of 17 the whole square, if you work out, this will work out to this root 17 can be written as 17 raised to 1 by 2. Okay. Root 17 can be written as 17 raised to 1 by 2 whole raised to this 2. Okay. Now, next will be this 2 and 2 will cut and you will get just 17 raised to 1, which is equal to 17. Now, this is a rational number. So, even though you are able to see a radical sign over here, don't jump to the conclusion that it is a irrational number. Then, moreover, you'll see that it's 17, the radical is not a perfect square. So, you will again feel that it is an irrational number. No. If you work out the square of this root 17, it will ultimately give you 17, which is a rational number. So if it is a rational number, it cannot be irrational. So the question was, which of the following numbers are rational? So first one is this. This is a rational number. Root 3, no, it is a perfect irrational number. 3.14, yes, it is a rational number because 3.14 can be written as 314 upon 100, which is of the form of, P upon Q, where PQ belongs to integer, Q not equal to 0. So 3.14, of course, is a rational number. Root 12 upon root 3 again can be written as a rational number. It is a rational number. You know why? This root 12 upon root 3 can be written as root of 12 upon 3, which is equal to root of 4, which will reduce to 2, and 2 is a rational number. Okay, so root 12 upon root 3 is a rational number, right? Pi square, now pi is an irrational number. An irrational number multiplied by irrational number will always be a irrational number. Now see, this is not always true. An irrational number and an irrational number when multiplied, okay, should give you a rational number also many a times. Okay, but these are different case. Okay, these are exemptions. But normally pi multiplied by pi will give you another number which will be irrational only, because pi is an irrational number. Okay, so pi square will be irrational. 3 raised to minus 1 plus 3 raised to minus 2 will be rational. It is very simple, straightforward. 3 raised to minus 1 is 1 upon 3, and 3 raised to minus 2 is 1 upon 3 square. This is nothing but a 1 upon 3 plus 1 upon 9. Now this will work out to a number which will be always a rational number, not an irrational number. Now 7 raised to 1 by 2. Now 7 raised to 1 by 2 can be written as root of 7. See, 7 raised to 1 by 2 can be written as root of 7. Now when you talk about root of 7, it is coming under a radical sign, and moreover this 7 is a non-perfect number, non-perfect square number. So if it is a non-perfect square number, it has to be rational. So this is irrational, not rational. Okay. 22 upon 7, of course it is a rational number because 22 is integer, 7 is integer, moreover 7 is not equal to 0. So it is satisfying the definition of rational number. So 22 upon 7 is a rational number, right? Now don't get confused. 22 upon 7 many a times we use for substituting for pi. Okay, so pi many a times in the earlier classes, lower classes you might have studied. Teacher will tell you either you use pi or you can use 22 upon 7 for pi. Okay. Now 22 upon 7 and pi both are almost same. Okay, almost equal to each other, but the major difference is pi is an irrational number and 22 upon 7 is a rational number. Okay, but they both have almost the same value. Okay, root 2 plus 1. Now root 2 is irrational number. Now if you add any rational number to an irrational number, you will always get an irrational number. Okay, so root 2 plus 1 is irrational number, it is not rational. And last one is square root of 2.25. Now 2.25 is a perfect square, right? And square root sign ke andar if you have a perfect square, then that will get converted into a rational number, isn't it? And rational, this will be a rational number. So that is why this will be a rational number. So out of these, this is one which is rational, this is another which is rational, this is rational, this one is rational, this is rational, and this is rational. All others are irrational numbers. Okay. Now coming to our next question, that is question number 4. Now in question number 4, they have given you two triangles A and B. You can see here the triangles both are right angle triangles. Okay. Now in the triangle A, you have hypotenuse 5, and this particular perpendicular is 3 and the base is x. In the B triangle, hypotenuse is x, the perpendicular is 5 and the base is 4. And this is that angle theta given in both the case. Now let us deal with one by one each and every question. So A part of the question is, for each of the triangle A and triangle B, find x. Okay. So let us do the solution. Now for A, if you want to find out x, we are going to use Pythagoras theorem. So by Pythagoras theorem, we can say phi square, the hypotenuse square, is equal to the sum of the other two sides ka square. So phi square will be equal to 3 square plus x square. So can you write this way? Phi square is equal to x square plus 3 square. Now if you take 3 square on this side, it will become phi square minus 3 square equal to x square. Now phi square minus 3 square can be written as 5 plus 3 into 5 minus 3. That is equal to x square. Now 5 plus 3 is 8 and 5 minus 3 is 2. So 8 into 2 will be x square, 16 will be x square, so x will be 4. Got it? So for A triangle, your x is 4. Similarly, for B triangle, your x will be root of 41. Same way. Okay. Here the hypotenuse is x. So x square will be equal to 5 square plus 4 square. 5 square is 25, 4 square is 16. 25 plus 16 is 41. So x will be equal to root of 41. Now here, in the B part of the question, they asked you, for each triangle A and B, state whether the perimeter is rational or irrational. Okay. Now, we'll have to find out the perimeter of both the triangles. So, triangle A, may the perimeter will be, perimeter is the sum of the boundary. Okay. So, for A triangle, the perimeter will be 5 plus 3 plus 4. That works out to 12, and which is a rational number. For triangle B, the perimeter will be 5 plus 4 plus root 41, because in B, the x is root 41. So this happens to be 9 plus root 41. So irrational number plus a rational number will always give you irrational number. Okay. So the answer for B is that this is rational. Triangle A ka perimeter is rational and triangle B ka perimeter is irrational. Now coming to the C part of the question. For each triangle A and triangle B, state if the area is rational or irrational. Now let us find out the area of both A and B and see whether they are rational or irrational. So area of triangle A will be half into base into height. So half into 3 into 4. So this 2 will cut. You will get 2 over here. 2 and 4 will get cut and you will get 2 over here. 3 2s are 6. So this 6 centimeters square is the area of the triangle A, which is of course rational. Area of triangle B will be half into base into height. So it will be half into 4 into 5. 2 and 4 will cut and you'll get a 2 over here. 5 2s are 10. So you get 10 centimeters square. This is the area of the B triangle. Now which is rational? Of course, both are rational numbers. Okay. So area of triangle A as well as area of triangle B, both are rational numbers. And the D part of the question is, in which triangle sine theta is irrational? Now, if you see this triangle A, इसमें sin theta is opposite upon hypotenuse. So, sin theta is 5 upon 3. Now, 5 upon 3 is what? It is an irrational number, right? Sorry, rational number. So, for triangle A, sin theta will be rational. And for triangle B, the sin theta will be opposite upon hypotenuse. So, it will be 5 upon x. But x is root 41. So, 5 upon root 41, you will get the this thing, sin theta. And 5 upon root 41 is nothing but irrational number. Okay. So the answer for the last question is like D part, that sin theta equal to 3 upon 5 for triangle A is a rational number, and sin theta, which is 5 upon root 41, that is the for triangle B, that is irrational number. Okay. Now in triangle B, sin theta is irrational. In triangle B, the sin theta value is irrational. Why? Because of this root 41, which is irrational number. Now coming to the next question, that is the fifth one. A circle of radius 3 centimeters is drawn inside a square. So there is a square inside which a circle is drawn and the radius of the circle is 3 centimeters. Write down the exact value of the following and state whether the answer is rational or not. A part of the question is circumference of the circle. Now this circle has a radius of 3 centimeters. So circumference will be equal to 2 into pi into r. That is 2 into pi ka value we will take as 3. Sorry, 2. No, pi ka value take as pi only. So this will be 2 into radius will be 3. So 2 into 3 is 6 and this pi you keep it as it is. So this will be 6 pi centimeter square. Now as I told you, 6 pi is nothing but an irrational number. B part, diameter of the circle, diameter will be twice radius. Radius is 3, so it will be 6, which is rational. Area of the square, C. Area of the square will be, now because this radius is 3 centimeter, if you double the radius, you will get the diameter of the circle, and which is equivalent to the side of the square. So side of the square happens to be 6 centimeter. Okay. Now what is the area of the square? It will be 6 into 6, 36, and 36 is a rational number. D part of the question is area of the circle. Now area of the circle is pi r square. So pi you keep it as it is, and r is 3. So 3 square will be 9. So it will be 9 pi centimeter square. And because pi is irrational, 9 pi will also be irrational. So area of the circle is irrational number. E. Find the area of the shaded region, whether it is rational or irrational. Now, area of the shaded region will be area of the square, which is 36, minus the area of the circle, which is equal to 9 pi. Now, 36 minus 9 pi will work out to 36 minus 28.2, which works out to 7.73 dot 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 dot. When there's dot 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 dot, that means it is an irrational number. That was question number 5. Let us come to the last question, question number 6. Is it possible to multiply a rational number by an irrational number to give a answer which is rational? So he is telling you, if you have a rational number and if you multiply it by another irrational number, is it possible that you will get a rational number? No, it is never ever possible to get a rational number, because the rule says that a rational number multiplied by irrational number will always give you a product which is irrational. Okay, so this first one is answer is no. Second is it possible to multiply two irrational numbers to get a rational answer? And the answer is yes. Any irrational number multiplied by the same irrational number will give you a rational number. For example, suppose you take root 5 and multiply by root 5. Both are irrational number. But the answer that you will get is 5, which is a rational number. Okay. So yes, two irrational numbers can be multiplied to get a rational number. And the last one is, if either or both are possible, give an example. So we have given the example over here. 5 into root 3 will be 5 root 3, and root 3 into root 3 will be 3, which is an irrational number. So with that, we come to an end of this session as well. And this was the end of the numbers chapter. Okay. And in the next videos, we'll be starting with ratio and proportion, percentage, and all those other concepts of algebra related to these numbers. So that will be in the next video. Till then, goodbye. Take care, all of you. And if you happen to like my video, please subscribe my channel and motivate me to make more and more such videos. Bye. Take care.